All right, can y'all hear me okay? Let me know down in the live chat if you can hear me okay. Can you hear me? Can you see me? Can you see my screen? See, Wilson says yes. Nathan says yes. Awesome. Let me know where you're tuning in for the stream tonight. I think we saw somebody come in from we got Florida, we got Hong Kong, Florence, Australia. Ottawa, Southern California, Las Vegas, LA. Bali, awesome, Canada, New Zealand, Alabama, Montreal, Spain, California, Seattle, New Jersey, Long Beach, Dallas, Texas, Istanbul, Romania. We got a crowd from all over the place tonight. I'll give us one more minute while people are still rolling in here, and we'll get started. We got Nigeria, Minnesota, Portland, Sao Paulo, Iowa, Utah, Atlanta. Coming from London too. All right, so let's go ahead and get started here. So welcome to the Trading Bot Masterclass. Okay, so I'm super excited to show you, how to create your own blockchain-based trading bot. There's a lot that's happening in this space, and there's a ton of opportunity with these bots, and I'm super excited to show you how to create one tonight. So, what we're going to cover tonight is basically, what you need to know to create a blockchain-based trading bot. We're going to talk about all the concepts that you need to know, all right, all the big ideas that you have to understand in order to implement this. And then also we'll give you an exact coding implementation that you can customize and then use, run and also create your own bots. So I'll go over a couple quick house rules this evening before we jump into our presentation here. So definitely, stay inside the YouTube chat for all your discussion. Okay, so if you're inside the Blockchain Mastery program, we have a community for that. But I'll only be watching the YouTube chat tonight. It's too hard for me to try to watch the community chat and also the YouTube chat. So any commentary, let's just keep it in the YouTube chat. So if you're not a part of the Blockchain Mastery Program, you just joined the one-time class tonight, and you want to, unlock all those other benefits like, weekly updated videos on, how to create, blockchain-based applications, trading bots, DeFi, NFTs, flash loans, all that type of stuff. You want to get that plus all the past master classes we've done, all the admission to future master classes, and definitely reach out to Gregory at dappuniversity.com. We can get you taken care of. So, in terms of the chat and questions, though, I'll be periodically monitoring the chat throughout the presentation tonight, but I do want to try to give my full attention to the presentation itself. So I'll pause periodically and glance at the chat, but let's try to save most of our questions for the end of the presentation. We'll have an extended Q&A time at the end. So also, once we get to the coding portion, all right, my recommendation is try to go through this presentation tonight live and then do the implementation at another time, and just rewatch it for the step-by-step instructions, okay? It can be kind of hard to follow everything in real time, so you might fall behind and you might miss some things. So definitely recommend going through this again and then using the link down below to grab the code and then setting all that up and customizing it. So, we're not going to do exact step-by-step coding tonight, but we'll show you how to set the bot, how to run it, how to customize it. There's a link down below to grab the code. If you don't see that, just make sure you refresh the YouTube page. It might have gotten added after you join the stream, but it's down there. Okay. And, while we're not going to do exactly step-by-step coding, it would take way too long to build the entire thing from scratch. If you want to see, how to load code for blockchain step-by-step, you want to polish up those blockchain skills, you can create your own custom trading bot. That's exactly what the Blockchain Bootcamp's decided to do. And you can grab your special discount offer below the stream tonight. There's a link down below next to the code. So last but not least, housekeeping item before we get on to our presentation. I always have to have the disclaimer that we're not promising any type of financial return, okay, based on our presentation tonight. This is going to be for educational purposes only. So, we're going to show you how to create this crypto trading bot, how to customize it. But because I can't guarantee any type of financial return from doing this, we're not going to dig into questions on like how much money you're going to make with trading bot, all that type of stuff. So just with all that being said, out of the way, we're going to get a ton of value out of this jam-packed presentation tonight. So let's jump in and get started. All right. So first of all, let's talk about how this blockchain-based trading bot works. Okay. So let's dispel a potential misconception, okay, that a lot of people have about trading bots. So some of those popular types of trading bots out there are essentially trading bots that try to predict what cryptocurrency prices are going to do, go up and down. Is it going to go up next? Is it going to go down next? And they try to predict what the price is going to do so they can buy and sell, use leverage, short, all that type of stuff. But that's not what this bot tries to do. Okay, this doesn't try to actually predict what the future cryptocurrency price is going to be. Those bots can be profitable and they can work, but sometimes they're going to blow up and you can easily lose money with those types of things. So, you need money to trade with those, and often like you're gonna lose it. So, that's not how this bot works. This is completely different. So, this is a blockchain-based trading bot that works completely differently. All right, it does not try to predict the future. It doesn't have to know what's going to happen next in the crypto market. It seizes opportunities that exist right now. Okay, and you don't really need money in order to trade. Okay. Now there's a caveat on that. You need money to pay gas fees in order to do transactions, but you don't have to actually hold the cryptocurrency that you're buying and selling whenever you are doing it. And you really can't lose the money, all right, that you're trading with. Now, there's also a small caveat there. If you attempt to trade when you pay gas fees, of course, if that trade is successful, then you can lose the money on those particular failed trades. So that's a small caveat there. But big picture is you're not talking about a bot that's just gambling on the future cryptocurrency price that's going to blow up and then blow your account. So what are the features of this bot? Okay, so this is what is instead called an arbitrage trading bot. So instead of trying to predict the future price of cryptocurrency, it looks for opportunities that are in the marketplace right now. Okay, so it's looking at different cryptocurrency exchanges and saying, where can I buy cryptocurrency right now and then sell it at a higher price somewhere else? That's what arbitrage is, basically buying low and selling high. And those price discrepancies happen all the time in the crypto space, and it simply capitalizes on those opportunities. So it's blockchain based, all right? So it uses smart contracts on a blockchain, all right? So it doesn't talk to the centralized exchanges like Binance or Coinbase. It looks at decentralized exchanges like Uniswap and SushiSwap. We'll go over all that. And then finally, it's powered by flash loans, okay? So we're going to get to all these details, but this is the overview. Basically, with flash loans, you don't really need the money that you're using to trade. You can simply borrow it and pay it back instantly. And it's risk-free in the sense that you cannot lose the money. Like it's impossible to lose the money that you're borrowing whenever you are making these trades. Okay. So we're going to cover tonight is everything you know to start creating your trading bot, all the concepts. Okay. Comprehensive overview of how the trading bot works with some diagrams so that you can understand it in depth. And then we're going to cover the implementation, so the actual coding implementation, the setup, the demonstration, and how you can use it to customize and create your own strategies. And we're going to focus primarily on the Ethereum blockchain tonight, okay? But because this bot's built in Solidity, or the smart contracts are, and we can point to the Ethereum chain, you can use this and point it to any blockchain that supports Solidity and Ethereum smart contracts, like Binance Smart Chain, Avalanche, any Ethereum layer 2 ecosystem. There's lots of different blockchains that you can apply this to, but we're going to focus on the Ethereum blockchain tonight as sort of a central reference point for that. Okay. So also, in this class tonight, what I'm going to do is teach you how to create a blockchain-based cryptocurrency trading bot. I've done this class before where I've created a strategy, like one of my strategies, and just given it away. Okay. And you can check out one of those past master classes if you want to see that strategy. It's in the video vault of the Blockchain Mastery Program. But the problem with doing that, okay, is like once I create the strategy and give it away, all right, as you can see, of over 100 people that are watching the stream right now, all those 100 people are basically going to be running the exact same strategy and competing with one another, okay? So really the best way to do it is to show you how to create a cryptocurrency trading bot, show you an implementation, and show you how to customize it so that you can come up with unique strategies so that you're not all competing with one another to do the exact same thing. Because ultimately, when you're doing arbitrage trading, you really have two opportunities, okay? One is you can, basically try to be better than everybody else. So you could take the same strategy and then just be the most competitive person, okay? Or you can try to tweak your strategy and look for other opportunities, okay, that not everybody else is doing. And that's really what I advocate for, okay? So in order to do that, you need the nuts and bolts on how to create a cryptocurrency trading bot, learn how to do it, and then customize it so that you can, come up with a unique strategy. And that's exactly what we're going to show you how to do. We're going to show you the finished bot solution and how you'll need to customize it to make it work. And then we're going to give you a good simulation environment so that you can watch your trades happen in real time, okay? So you can sort of think of like a flight simulator. So if you're going to fly an airplane, the best thing for you to do is get inside of a simulation cockpit before you try to take your airplane out on the runway. Because the last thing you'd want to do is say, hey, I want to learn to fly a plane, and then get in a plane and hit the gas, right? That's probably not the best idea. So that's basically what I'll show you how we're going to do that tonight, right? Because you'll want to learn to fly the plane before you actually achieve liftoff. And I'm going to show you an environment you can do that without trying to burn through all your money and waste it on stuff that may not work right out the gate. So let's go ahead and start off with the concepts that you need to understand in order to make this bot work, okay? So let's start off with the fundamentals of arbitrage, okay? So before I was talking about this is an arbitrage trading bot that looks for price differences on different cryptocurrency exchanges, and essentially exploits those differences. I say exploit, I don't mean like hack or steal money. There's nothing really unethical about this. It's really just taking advantage of an opportunity that exists on the table and then buying low and selling high. So what that looks like is this. You can see an exchange here on the left, exchange A, okay? And let's say a cryptocurrency sells for $100 on exchange A, all right? And then on exchange B, you sell it for $101, all right? So you can buy it on exchange A and sell it on exchange B, and you make a $1 profit, all right? So nobody gets that excited about a $1 profit, but what if you could do that, with 1,000 units of this cryptocurrency token? So like if you could buy 1,000 tokens on this exchange and sell it on this exchange, that'd be a $1,000 profit. Or thinking of it a different way, what if you could do it with 10 tokens and you could do it, 100 times? Well, that's still a $1,000 profit. You're just doing it over and over and over again. All right. So, you can do this with regular cryptocurrency exchanges right now. You don't even necessarily need a bot, right? Like you can get on a centralized exchange like Binance and Coinbase and FTX and watch the price differences of, Bitcoin, for example. All right. cryptocurrency is very volatile. It goes up and down like crazy. And that's how arbitrage opportunities happen, because those exchanges essentially fall out of sync. Okay. And so, the price of Bitcoin always has like some small difference on each exchange. And so you could do that, right? But there's a problem. Like if you were going to go buy Bitcoin on, Coinbase and sell it on FTX or Binance or whatever, some other exchange, the price might move on you by the time you have actually transferred funds from one exchange to another. Okay. Now there's definitely strategy you can do to like keep money on each exchange and then buy and sell based on that. But still, like there's no instant connection between those two things. Okay. But that's where the blockchain comes into play. All right. With a blockchain based trading bot, you can create smart contracts that hook into decentralized exchanges that are powered by smart contracts themselves, like Uniswap and SushiSwap, or any other decentralized exchange out there. And whenever you create a contract that talks to those things, you can buy and sell instantly, and there's no possibility that the price can move on you. Okay. Like if you have if the discrepancy exists, it will exist for the entire time that the transaction is going through. Okay. So that's the benefit of the blockchain-based trading bot that we're doing now, is because you can hook into everything on chain. So now let's talk about flash loans, okay? Because this is the real benefit, is you don't need, any capital in order to trade. I mean, again, you need some money to pay the gas fees, but you don't need any cryptocurrency in order to, execute an arbitrage opportunity. So something called a flash loan. So basically, this is a technique where you can borrow millions of dollars of cryptocurrency for free with zero money down, as long as you pay it back in the same transaction. Okay. So you might think like, how on earth can you get a zero money down loan for free? Okay. Well, basically that's because of the blockchain. There's no, essentially whenever you're doing a transaction, let's say that I'm sending cryptocurrency from my account to yours. Okay, that's a single transaction. All right. Or if I'm going to swap a token on Uniswap, that's a single transaction. Well, inside those transactions, you can implement complex steps like, buy cryptocurrency, sell it, transfer it, move it around, all that type of stuff. That's multiple steps that you can do inside the same transaction. So you can do things like step one, borrow cryptocurrency with a flash loan. All right. Step two, do something with the money, like, buy crypto tokens on exchange A. And then step three would be, sell the crypto tokens and then pay the money back with the flash loan. And then step four would be keep the profit. So that's what a flash loan is. All right. And that's how we're going to hook our flash loans into our cryptocurrency trading bot, so that you don't have to have any money in order to execute those trades. So now I want to talk about some caveats with flash loans. Of course, they're great because you don't need the money. They're basically free. All right. But just because you can borrow $1 million of cryptocurrency doesn't mean you always have to. Okay, we'll get into that tonight. If you can do smaller flash loans when you're talking about smaller trades, you won't always be trading like $1 million of cryptocurrency on each arbitrage. All right. When I say for free, it's basically free. There is a small fee that you will have to pay to the flash loan provider, but sometimes it's so small that it's basically free. All right. There are even flash loan providers out there that are 100% free. Okay. They're a little more complex to implement, but they do exist. And it's zero money down. Okay. Because what I mean is you don't have to provide any collateral in order to take out the loan, but there will be a small, transaction fee for that loan, like I was talking about before. So now let's talk about what cryptocurrencies you can trade inside this, okay? Somebody's saying they can't find the code. The code is in the link down below. We'll be able to rewatch this. Yes, if you join tonight into the Blockchain Mastery video vault, we'll post a replay, and we'll also email out a replay whenever we're finished. So let's talk about what cryptocurrencies you can trade. So what we're going to trade tonight are Ethereum-based tokens. Okay, so that means that, or ERC20 tokens. So the cool thing about Ethereum and other EVM compatible blockchains and other smart contract platforms is that you can create a new cryptocurrency without creating a new blockchain. Okay, so you might think about a cryptocurrency like Bitcoin. Bitcoin is a native cryptocurrency, the Bitcoin blockchain. If Ether or Ethereum is the native cryptocurrency, the Ethereum blockchain. But if you look at all these other coins like Tether, okay, USDC, let's just see, the Uni token, Quant, ApeCoin. All these are ERC20 tokens, which basically means that the cryptocurrencies are powered by smart contracts on top of the blockchain. And so ERC20, what it is, it's just a standard that specifies how these smart contracts work so they're compatible with wallets, compatible with cryptocurrency exchanges, all that type of stuff. And any ERC20 token is what you're going to be able to trade with this bot. So, for example, you can't trade Bitcoin natively like this, but there are like wrapped Bitcoin versions, which are ERC20 compatible, like wrapped Bitcoins, WBT. So this tracks the price of Bitcoin. If you're going to trade Ethereum or Ether, you have to wrap it with WETH. All right. But everything else that's natively a token works, just like this. And the nice thing about these ERC20 tokens is that they're compatible on any other, EVM compatible chain, like I was saying before, like Binance Smart Chain, like Avalanche, like any of these others. Okay. And these tokens won't just exist on Ethereum. They'll also exist on many other blockchains as well because they follow this standard. And those are the types of cryptocurrencies to be able to arbitrage. And the other thing about this bot is that it exists on one blockchain at a time. So somebody asked me, can they like arbitrage cross-chain, like from Ethereum to Solana, for example? So you can't do that natively. You have to be inside the same blockchain. And last thing I'll show you here is if you want to get an idea of how these tokens work, here's an overview of the ERC20 standard. So basically, this is what I mean by they follow a standard. So they have a standard set of functions on them, like each token has a name, symbol, decimal, total supply, all that type of stuff. They emit certain events, and we'll see that inside the code, but this is the ERC20 standard spelled out in detail. So now let's talk about decentralized exchanges, okay? Because these are the types of exchanges that we're going to be buying and selling cryptocurrency on, all right? So these are going to be decentralized exchanges like Uniswap, all right, like Sushi Swap, okay? So, these are blockchain-based exchanges. They work differently from something like, Binance or Coinbase or FTX or Gemini or whatever you use to trade, because they are powered by smart contracts on the blockchain. So if you look at my screen, this is the Uniswap front end, okay? This is a website, but this website doesn't talk to a server that holds all your money, okay? It talks directly to the blockchain, and it talks to smart contracts, and that's where, the actual trading happens. So it looks like this, right? You essentially have this website. That's what I showed you a second ago. And this website talks to a smart contract, or really a set of smart contracts, but we'll just call it a single smart contract for example purposes. All right. And these smart contracts talk to other smart contracts called liquidity pools, okay? And this is where all the money is that you're going to be trading, all right? So Uniswap was called an automated market maker. So instead of being on a cryptocurrency exchange like Coinbase that has an order book with a bunch of, buy and sell orders in it, and, liquidity providers in the back end who might be facilitating some of the trading volume there. All the funds just sit inside these smart contracts, okay? And then you have decentralized wallets who are just, externally owned accounts who provide cryptocurrency to these trading pools, okay, these liquidity pools, so that the cryptocurrency exchange actually has money in order to operate. Because if you go to Uniswap and you say, I have ETH and I want to buy a different token, let's just say the Matic token, for example, where does the Matic token come from? All right, the ETH comes from your wallet, but the Matic token is just sitting inside of a smart contract here that these decentralized liquidity providers, which is just anybody with cryptocurrency in a wallet, can provide liquidity to Uniswap, and then they basically get a passive income opportunity as an incentive to do that. Okay, and so on Uniswap, essentially you're pairing two different cryptocurrencies in each pool, okay, and those represent the trading pairs that happen on the exchange. And then on the back end, Uniswap routes the orders depending on which tokens you want to buy and sell. So each time you look at these liquidity pools, you'll see examples of like USDC WETH. That just means that there's USDC cryptocurrency and wrapped Ether or WETH in this pool. And this one is an example of like the Shiba Inu token, like SHIB and WETH in this pool. And so you can actually see examples of this on Etherscan. I've got pulled up like the Uniswap liquidity pool for the Shiba Inu token and the WETH token. And so you can see inside of here, there's equal weights of each of these tokens. That's how the automated market maker works. You provide equal weights in US dollar amount. So there's like $700,000 with the Shiba Inu tokens and $700,000 roughly of wrapped Ether tokens. And similarly, here's the SushiSwap pool. So there's like $1,000 in here and $1,000 there. So you provide equal weights of each cryptocurrency, and that's where those funds are that you are going to trade. And so the nice thing about this is that because this decentralized exchange is all powered by smart contracts, it's completely permissionless. All right. So basically, whenever you are talking about buying and selling cryptocurrency from these pools, then you have open access as a blockchain developer to create your own contracts that hook into each of these pools in order to facilitate that. Okay, so that's exactly what we're going to get into whenever we show the code. Is you're going to be writing your own smart contracts into this. You don't have to have any API keys. You don't have to have any special permission. Anybody with access to a blockchain who can put contracts on there can create bots or any contract they want to that hooks into these contracts themselves. And the last thing I'll say about this is sometimes people ask me like, hey, where does the money come from whenever you're taking out flash loans? Well, in most cases, the flash loans actually come from liquidity pools of decentralized applications. So there's different flash loan providers out there. We'll show that here in a minute. But essentially, there's not many apps that essentially are really just flash loan apps in and of themselves. It's usually a secondary function of those applications. So if you're going to borrow $1 million of cryptocurrency, there's usually $1 million sitting in a liquidity pool somewhere for a decentralized exchange, for example, or maybe some other lending protocol, savings lending protocol that you can take flash loans out of because they're all powered by these liquidity pools. All right, with that being said, let's jump in and take a look at how the bot works. Okay, so that's an overview of flash loans, an overview of decentralized exchanges. Let's look at the actual trading bot. So let's look at the different parts of the trading bot. So there's two main parts, and I've got a line here on the diagram to show you like what's on the blockchain and what's not on the blockchain. Okay. So let's start off with the blockchain side of things. Okay. So what you're going to do as a developer, the heart and soul of your trading bot is the execution environment. So the execution environment is all on the blockchain. It's really just one smart contract, okay, that facilitates buying on exchange A and selling on exchange B, and it also orchestrates taking out a flash loan. All right. So you're going to connect your smart contract to three different things. You're going to connect to the exchange you're buying or selling on, exchange A, and the second exchange B, that you're buying or selling on, depending on the order. And then you're also going to connect it to your flash loan provider. So exchange A could be Uniswap, it could be SushiSwap, and that's where like token 1 will come from when you buy it on exchange A. And then exchange B, maybe the same type of thing, maybe it's SushiSwap, and then you'll have token 2 over here. But first and foremost, you need to take out the flash loan in order to do that. So you'll connect your smart contract to the flash loan contract as well. So an example might be DYDX, Aave Sushi Swap, or Uniswap, depending on what you're going to do. And so, inside your smart contract, of course, is going to be written in Solidity. It's going to govern all the rules of your trading strategy. This will be where you're able to take out that loan. You can't lose that money, and all this is on the blockchain. So that's the first part of your trading bot is the execution environment, which we'll see here in a minute. The second bot part is the actual robot part. And this is what people think of as a bot, which essentially is a process that runs on your computer, okay, that watches these different cryptocurrency exchanges and watches for trades that go through, and then actually looks at the prices of the cryptocurrency on each exchange to determine if it wants to perform an arbitrage trade, okay? And so this bot, when it watches each of those exchanges and it actually detects an arbitrage. And when it detects an arbitrage, it will call your smart contract to execute the trade. Okay. So it's really two things. You've got your contract here that does all the execution, and the bot that watches up for the opportunity and then talks to your contract on the blockchain to actually do the trade. And so this bot is like on your computer. Maybe you run it in the cloud. It's really just an app. Okay. It's a script that runs. It's written in JavaScript, and your contract on the blockchain, it's written in Solidity. So let's look at the details, of your bot here. So your bot, what it's going to do is it's going to watch the exchanges that you talk to, and it's going to monitor every single time that a trade happens on that exchange, okay, for the particular trading pair that you are watching, okay? And so essentially, you want to watch every single swap event that happens, and then your bot's going to evaluate that swap. It's going to say, okay, a new swap event came in. I'm going to run the math and say, can I profit? If I don't, I'm just going to do nothing. I'm going to skip it and wait. Okay. But if I can profit, then I'm going to call the contract and execute the trade. And then your contract, once it executes that trade, it's going to perform multiple steps. It's going to take out a flash loan for token 1 that you're going to buy. It's going to buy that token on an exchange A, and then sell that token on exchange B, and then pay that flash loan that you took out, and then keep the profit. Okay. And so the other specifics of your particular bot, all right, are going to be essentially, here's your bot, here's your contract. Tonight, what we're going to show you how to do is arb between Uniswap and Sushi Swap. Okay, these are two exchanges that have an identical interface because the Sushi Swap project is a clone of the Uniswap project. So once you learn how to work with Uniswap version 2, you'll be able to work with Sushi Swap as well. And what we're going to do is we're going to arb the WETH token. All right, that's what I'm going to show you how to do tonight. And also the Shiba Inu token. So WETH is a wrapped version of Ether. It's the ERC20 version like I was talking about before. And the Shiba Inu token, of course, is just the Shiba Inu token, which is always an ERC20 token. And we're going to use DYDX as our flash loan provider. Okay, so let's look at a couple other things before we look at the technicals. We're going to jump into the coding here momentarily. But one other thing I want to talk about is this. So, tonight we're going to focus on Ethereum and focus on these two exchanges that I talked about, and also focus on these two tokens just to show you how to get started. But I want to talk about the opportunity here because, before I was talking about, everybody could do the exact same strategy and you could try to compete with one another, or you could try to craft your own strategy, which I think is the best option here. And so let's talk about what that opportunity looks like. So, this is just two exchanges. There's just one flash loan provider. It's just one token trading pair. It's just one blockchain. But think about this. All right. You've got all these tokens here. Okay. This is a page of 50 tokens. All right. And there's 20 pages of this, and that's just what Etherscan shows on its top token pages. But if you go to like CoinGecko, there's thousands of ERC20 tokens out there on Ethereum alone. All right. And then you multiply that opportunity by the number of decentralized exchanges. Okay. I've got a decentralized exchange list pulled up here on DeFi Llama. All right. This is a list of 115 decentralized exchanges. Okay. So multiply thousands of tokens by, at least 100 exchanges. All right. And then, like I was saying before, you can take this exact code and use it on different blockchains that support Ethereum smart contracts, any EVM compatible chain, like you see here. So this is easily a few dozen different EVM compatible chains that you can also execute these same strategies on. So when you're talking about mixing and matching those opportunities, it's a really, really big number of combinations. All right, so the last thing I want to note here before we let's talk about our flash loan provider we're going to use tonight. So the flash loan provider we're going to use tonight is with DYDX. Okay, so why DYDX and what is it? So DYDX is a derivatives trading platform. Okay, on multiple environments. Okay, so they started on Ethereum. And DYDX is a great flash loan platform on Ethereum because it has some of the lowest possible fees that you can borrow. Okay. So basically, their fee is one way per flash loan, which basically means if the token has 18 decimal places after the zero, it's like one tiniest, smallest fraction of that cryptocurrency you can possibly do. So it's basically free. All right. So some alternatives to this, if you want to use other flash loan providers, Aave is a popular one. They have a higher fee of 1%. There's also Dodo, which works on multiple blockchains. They are completely free. Okay, you can look at the Dodo docs, although Dodo's implementation is a little more complicated than DYDX. So that's why we use DYDX. It's the simplest and the cheapest, sort of all in one. It's a great resource for just plug and play flash loans. Okay, so now let's get into more of the technicals. So we'll go back to our diagram here. So again, we are going to be running our bot here. All right. We're going to be working direct with Ethereum. All right, on two different exchanges, Uniswap and SushiSwap with our contract. We're taking out loans from DYDX, like I was talking about. We're going to be arbing the WETH token and the Shiba Inu token. Okay. So what we're going to do tonight is show you how you can actually perform an arbitrage in real time. Like the best way to learn this is to actually get the conditions so that an arbitrage is there, and then execute the arbitrage so that you can see how the bot works, and then watch for these opportunities so that you can run it. All right. So it would be very hard for me to schedule this class in real time and just wait for an arbitrage to happen and then perform it live. So what we're going to do is basically create a simulation environment where we can fork the entire blockchain. Okay. And then basically manipulate it so that we can cause an arbitrage opportunity to occur, so that whenever we run the bot, it will actually do a trade. So instead of like sitting around trying to wait for a perfect opportunity, we can just manipulate it so that it happens. I'm going to show you exactly how we do that here in a second. Okay. So what we're going to do is use WETH on Uniswap and sell it for SHIB and then ARB it back and get more WETH. And so what's that sequence going to look like? Basically, we're going to take out a flash loan with DYDX for WETH, wrapped Ether, okay? We're going to trade that on Uniswap for Shiba Inu tokens, all right? And then we're going to get the Shiba Inu tokens and then trade them back on SushiSwap and get more more WETH. We're going to pay back the loan amount, and we're going to keep the profit that we did in this sequence. And the reason I want to show that sequence is sometimes that can be confusing when you say the words buy and sell. Okay, because really it's just a sequence of trades, and this is exactly what the sequence is. So now let's talk about how to recreate the arbitrage opportunity, because this is what we're going to do. Again, it would be really hard for me to sit here and run the bot and like wait for an opportunity to happen and then show a trade in real time. So what we're going to do is create an environment where we can actually do that. So we'll create a scenario where there's an obvious price discrepancy. And so what we can do is essentially take the blockchain, Ethereum in this case, and we can get a connection to it with an Ethereum node like Infura or Alchemy, okay? And then we can run a local blockchain on our computer like Ganache CLI, for example, and we can freeze the entire blockchain, okay? And then get a development copy of it. And then we can unlock all the accounts, all the contracts, all the balances, tokens, exchanges, etc. We'll have access to all that stuff, and we can manipulate it however we want to. So basically, and then we can connect our bot to it so that we can get this local copy of Ethereum that's, kind of different from their actual mainnet. And then we can manipulate prices to make the exchanges fall out of sync and actually execute the opportunity. So we'll be able to pretend like we're certain accounts on here. So example, you can see like this big wallet right here with a bunch of cryptocurrency inside of it. Of course, I don't have any special access to this wallet. Unfortunately, this is not my wallet with, $5 billion worth of tokens in it. But because we can fork the blockchain, we can unlock this account and actually move those tokens around so that we can manipulate the price in order to make an arbitrage event happen. So what you'll need to do this, what you'll need for this is a Ganache blockchain running on a computer. We'll get to that in a minute. And you'll also need a connection to an Ethereum node. In this case, we'll use Alchemy. So let's talk about how we're actually going to create this arbitrage opportunity. So just a minute ago, I had this pull up on my screen here. This is a really large wallet, okay, full of Shiba Inu tokens, all right? And what we're going to do is we're going to unlock this wallet, okay, on our local environment. And we're going to take like all these Shiba Inu tokens and we're just going to sell them, okay, on SushiSwap. All right. Again, we're talking about Uniswap and SushiSwap here because they have the exact same interface. And we're going to go to we're going to SushiSwap, and then basically we're just going to dump a whole bunch of Shiba Inu tokens. And what that's going to do is cause the price of Shiba Inu to drop like crazy. Okay. And then whenever that happens, there's going to be a massive price discrepancy on Uniswap and SushiSwap. And so then we'll perform the arbitrage because the prices will fall out of sync like crazy. Okay. And so instead of waiting for a price discrepancy to happen in real time, that's how we can create the situation ourselves and then watch the arbitrage opportunity happen. And, these arbitrage opportunities happen all the time because cryptocurrency is so volatile, the price goes up and down like crazy, but also because DEX marketplaces are so inefficient. Like you might have somebody dump a large amount of cryptocurrency and you have a bunch of slippage and it causes the price to go down. And then there's a huge difference on these exchanges, just like we're doing here, that could cause the opportunity to happen. So now let's talk about how much can you ARB, okay? Because that's a big question is people ask like, okay, I can borrow $1 million of cryptocurrency, but how much do I actually need to borrow and how much can I actually arbitrage? Okay. So first of all, let's talk about the liquidity pools. Okay. So again, all the cryptocurrency we're trading tonight is housed in liquidity pools on these, decentralized exchanges that are just giant reservoirs of money that power the applications. And each liquidity pool has 2 different cryptocurrencies inside of it. All right, so Shiba Inu tokens and wrapped Ether. This has $700,000 of wrapped Ether and $700,000 of SHIB, roughly speaking, okay? And so how do you calculate the price? Well, the price is really just the ratio of 2 different cryptocurrencies. So in this case, if there's 5,000 Shiba Inu tokens and 2,000 WETH, we express that price as basically roughly 2 SHIB per WETH. Let's say it's actually $2,500 in WETH. There's a small error on the screen here, but roughly 2 SHIB per WETH. Okay, so and then on Sushi Swap, let's say you had, oops, sorry, let me pull that back up. Lost my diagram here. Let's say on Sushi Swap, you had 1,000 Shiba tokens and 1,000 WETH. We express that price as 1 to 1, so 1 SHIB per WETH. All right, so how much can you ARB? Well, you're going to be limited on the smallest reserve. So if you're trying to ARB Shiba tokens, and there's only like 1,000 in here, well, that's going to be sort of your theoretical limit. Now, you also have to factor in the slippage that would cause on the price, but that's the whole idea. You're going to be limited to the amount in the smallest liquidity pool, okay? So in this case, if you're talking about WETH, you wouldn't really want to borrow more than 1,000 WETH for an opportunity like this because you wouldn't be able to do anything with less than 1,000 WETH. All right. So finally, let's talk about, calculating the profitability of an arbitrage, because, if you're buying and selling on an exchange, of course, you have to get back more cryptocurrency than you started with. That's the whole idea of arbitrage, is accumulating more of the cryptocurrency. But you also have to factor in the flash loan fee, okay? So in this case, we're using DYDX, which has basically a negligible fee. All right, so it's not really that much of a factor, but if you're using a different provider, you have to factor that in. And then you also have to add in the gas fee, okay? And that could be some of the toughest things to overcome, especially on a chain like Ethereum, although it is easier now that gas fees have gone down significantly while the space is a little bit quieter. But those fees are also greatly reduced on other lower fee chains like Polygon, Binance Smart Chain, all that type of stuff as well. So that is the strategy of combating those fees, is essentially using a lower cost chain. Okay, so now let's get into the coding. All right. So let's go ahead and grab the code, all right, down below. There should be a link in the coding in the video description. If you're watching this on the replay, there'll be a link down below. If you got the resources emailed out to you, there should still be a coding link in the YouTube description of the resources, wherever you have them. That's a zip file. Okay, I've got this GitHub repository pulled up here. You won't have access to this. This is private, but I have given you the zip file of the current version of this code so that you can download it. So go ahead and unzip that. All right, onto your computer. So for this coding section, the milestones, I'm gonna show you how to set the bot up. We'll demonstrate it. All right, I'll explain how the code works, and then we'll show you how to customize the code so that you can, change it and implement your own strategies. All right, so let's talk about some dependencies that you need on your computer in order to get this started. Okay, So, you'll definitely need Node.js installed. Okay. So if you don't have Node already installed, you can, of course, download it from the Node.js website. All right. But you can go to your terminal and see if you have Node installed by just opening your terminal, typing node-v. All right. I'm using Node 16.14.10. All right. So if you want to ensure success, I highly recommend using the exact same Node version as me. Okay. But if you're a developer already and you understand how to work with Node versions, feel free to use whatever you'd like. But just note that's what I'm using tonight, and that's the only thing that I guarantee will work. So another dependency is going to be Truffle. So that's the smart contract development framework that we're going to use tonight. Okay. So you go to your terminal and do truffle dash version. All right. So I'm using this version. And then you can install Truffle if you don't have it already with npm i-g Truffle. Okay. All these instructions are in your README file inside that code repository. And then finally, we're going to use Ganache CLI. So this is the development blockchain that we'll use to fork the Ethereum mainnet. Okay. So you can see if you have Ganache installed by doing Ganache -- version. Okay. So I've got it. I'm using version 7.1.0. If you don't have it installed, you can just do this. npm install Ganache -- global. Again, that code is instruction is in your README file with the code that you've got with the resources tonight. Okay. So go ahead and open that in your terminal. You're going to want to install your dependencies with Node like this. So npm install. All right, I've already installed my dependencies, so this will finish pretty fast for me. And then next, let's make sure that we have a URL to point to the blockchain. So tonight we're going to use Alchemy. So Alchemy is a Web3 platform that gets you access to a blockchain node so that you don't have to run one for yourself. Okay. So go ahead and create an account. Once you've created an account, you'll see the option to create an app. This is completely free. And then you'll just want to create an app and get a URL and an API key so that you can point your project to the blockchain if you want to listen to it on the mainnet. So for now, we're not going to use the mainnet directly. We're going to use our forked environment. But if you want to point to the mainnet, then this is what I recommend. All right, so now what we're going to do is we're going to start Ganache, okay? So I'm going to first start Ganache like this. You can just do Ganache. And that's going to start a development blockchain. I just typed Ganache and hit enter. And you can see what that does is it gives us a bunch of accounts, okay? And you can see that here's the accounts with Ether in them. Here's the private keys. Again, you don't want to use these accounts to hold real cryptocurrency because anybody's watched this video, of course, will have access to your funds. So that's just a quick security warning there. But what I want you to do the first time is see this mnemonic seed phrase, okay? So go ahead and copy that and then put it into a text editor, like just a separate note. Again, don't use this mnemonic seed phrase, all right? But you're going to copy that and keep it for safekeeping. So what we're going to do is basically use this to restart Ganache with the same set of accounts every single time. So you just go ahead and copy that and then start Ganache like this, okay? I've got this command inside the README here. We're going to use the fork option. We're also going to specify the mnemonic seed phrase so we can get it every time. And then we're going to unlock this account, okay? So essentially, let me explain exactly what these arguments mean. So Ganache just starts the blockchain. -F is the fork command. So that basically means take our blockchain, point it to Ethereum, and get a copy of all of the stuff on Ethereum so we can start, using all the accounts and the exchanges on there. -M lets you specify the mnemonic seed phrase, so you'll paste that in. And then -U, what that does is it unlocks a specific account so that you can pretend to be that account and sign transactions on its behalf. And so that's what we're going to do is unlock this specific account here. This is this Shiba Inu wallet that's got like $5 billion worth of Shiba Inu tokens in it, basically. Okay. So this is the account that we are unlocking in order to manipulate the price for the Shiba Inu tokens on the exchange so that we can actually perform an arbitrage. So if you want to, simulate some other token and, simulate some other strategy, you could unlock, let's say you wanted to arb, BNB tokens, you could get some massive BNB wallet and unlock it so you can manipulate the price. And then finally, the port -P is just the port that you're going to run on. So basically, you're going to do ganache -F forks -M. You're going to paste in your mnemonic seed phrase. I'm going to skip that step for now. And then you'll, let's say, foo bar. And then you're going to put in -U. All right. So now I'm going to go off screen and I'm actually going to put in my mnemonic seed phrase. It's not that big a deal. I'm not using a real mnemonic. Again, I highly recommend not using a real mnemonic here that you would hold money in because, yeah, that's a huge security vulnerability. But you do want to put your mnemonic seed phrase inside quotation marks. Okay, so I've done it. Again, you can probably see my mnemonic on here. It's not a big deal. It's not a real wallet, but you'll see. Yeah, I'll just show it to you. It's not a big deal. So ganache -F -M. Here, you put your mnemonic seed phrase in quotation marks here, and then do that. So now you can see the available counts. And what this is going to do is just let you restart it, and it's going to be the exact same. Accounts every single time. That's the nice thing. And you'll see that it's forked the chain. So it's forked the Ethereum mainnet. All right, you can see the block that it's forked at. You can specify the block number if you wanted to, the network ID, and you can see the date here. And here's the chain ID. Luke says 5 billion is what he used to buy breakfast. So somebody's talking about something a little too fast. Yeah, so I highly recommend using watching the replay to go over stuff because it will be kind of hard to keep up with some of this stuff in real time. All right, so now that that's started, all right, let's go ahead and open our project here. We'll give a quick quick overview. We've got the contracts for the arbitrage inside of here with the flash loans. Okay, we'll explain all this. Don't worry. But I'm just going to do a quick overview. We've got the bot code inside of here. All right, this is our bot process that runs. All right, we'll go over that. And then we also have a special script inside of here to manipulate the price of the Shiba Inu token so that we can make the arbitrage scenario happen. All right. And then, of course, we have our truffle configuration, which points our project to the blockchain. So if you want to point this to the Ethereum mainnet, you can update this. If you want to point it to Binance Smart Chain, Polygon, whatever, this is where you'll change that. All right, we'll talk about that more as well. And then finally, we have our migration script, which puts our smart contracts on the blockchain. So basically, we have all of this. Now, the last thing I want to talk about is the .env file. So I have a .env.example inside of here. So what is a .env? Well, a .env file essentially is where you keep all the environment-specific settings for your project. So if your project runs on your computer, that might have a different environment variables versus a server might have different environment variables. But the really important thing here is that the information in your .env file is secret. Okay, so you don't want to put your .env file. You don't want to show it to anybody And you also don't want to put your env file on GitHub or something like that. So if we have something like a git ignore inside of here, okay, we have already git ignored the .env, because like with the .env, you're going to have like your private key. So really, this is just a file that saves the settings for it. So what you're going to do is duplicate this and put a new file right here called .env. I've already done that, so I'm not going to show you mine on screen because, of course, it has sensitive information in it. But what you want to put in here, you can leave a lot of this the same. So the gas price, we can keep that the same for testing purposes. The gas limit, you can keep that. Units, you can keep that. Price difference, you can keep that. What you want to do is take the private key, okay, the first private key from your ganache here, and then just copy that and then put it in here, all right, inside the quotation marks, in your actual .env file, not the .env example file. And you're going to take that Alchemy API key that you created earlier with the Alchemy platform, and then put that inside of here too. So like, your Alchemy API key, right? And then finally, the two settings for the tokens, if you want to change this, these are the two tokens. So ARB4 and ARB again. So we got the WETH token and the Shiba Inu token. So you can change these out if you want to ARB between different tokens to customize a specific strategy. So, but you're all going to fill out all this stuff. You can leave most of this stuff the same for now. Just make sure you put your private key in there from Ganache and also your Alchemy API key, and put it in a brand new .env file, not the .env.example. All right, so now let's get into the next step. Let's now that we have our blockchain running, let's actually put the smart contract for the trading bot on our blockchain. So we've got this arbitrage contract here. We'll go over this in a minute, but here's the trading contract. We have our migration script. So let's go ahead and deploy those to the blockchain. So let's say truffle migrate -- reset. All right. So that's how you put the contracts in the blockchain. Use truffle migrate. Use the -- reset flag in case you've already put them on the blockchain. It'll deploy new copies. We see that was successful. All right. So your trading bot contract is now on your blockchain. You can see these transactions went through. So now let's start the bot. Okay. So what I'm going to do is actually open this up in a new terminal window here. And so our bot process is in this new file here, bot.js. All right. And so what we're going to do essentially is do node bot.js. Okay. And so now you can see that the bot is running. All right. It's listening on port 5000. It's logged this to the console. So the Uniswap pair address is this. The SushiSwap pair address is this. And now what it's doing is it's just waiting for swap events to happen. Okay. So it's going to sit there and listen for new trades to come through. And it's going to look at the price differences whenever those trades happen to determine if it can actually detect a profitable arbitrage. And if it does, it's going to call the smart contract that we just put on the blockchain in order to execute that trade. So now let's get into the final step. Let's actually watch an arbitrage happen. So remember before, I was talking about how essentially what we want to do tonight is create a sandbox environment where you can practice this. And I've created a script inside of here that's going to do exactly what we talked about before, which is going to take all those Shiba Inu tokens from that big wallet that we just unlocked, and it's going to dump them on SushiSwap to cause a massive price discrepancy. Okay. And then whenever that price discrepancy happens, our bot is going to detect that and it's going to fire the arbitrage. So let's go ahead and do that. All right. So how we do that is run the script like this. You'll see the command inside of your README here. You'll do node, and then you'll paste in the script location, which is ./scripts/manipulateprice.js. All right, so I'm going to do that in this window on the left. And then on the right, you can see the bot is waiting for this. And whenever I run this script, it's going to detect the price difference and it's going to actually do the arbitrage. Okay. So I'm going to hit enter over here on the left. Just watch my window on the right and it'll work. All right. Attempting arbitrage. And boom, there you go. Trade complete. So it just happened. It just worked. All right. So let me explain how that happened. So on the left, I'm going to go ahead and stop the script. You can see the script is outputting, beginning swap. The input token is Shiba Inu tokens. The output token is WETH, and the swap is complete. So here was the price before. 1 WETH was equal to this many SHIB, and the price after 1 WETH equal to this many SHIB. So basically, it just dumped a whole lot of Shiba Inu tokens and caused the prices to fall to sink like crazy. Okay. And then on the right, you can see our bot was running. All right. So it detected a swap event. So it said a swap initiate on Uniswap, checking the price. So current block is this. All right. So Uniswap, SHIB, WETH. And then you can see the price, and then Sushi Swap, SHIB, WETH, here's the price. So it calculated percentage difference. It's a massive percentage difference, okay, because we just dumped an insane amount of Shiba Inu tokens. In the real world, you're probably not going to see these types of price differences, but I wanted to make a very obvious price difference so that you can see a very obvious arbitrage here. So it'll determine the price direction. All right, so the potential arbitrage direction is buy on Uniswap, sell on Sushi Swap. It calculates the profitability. So here's the reserves. So here's the SHIB reserves, here's the WETH reserves. It's the estimated amount of WETH needed to buy the SHIB is this much, and the estimated amount of WETH returned after swapping would be this much. Okay, so this is how much WETH we'll get back. Here's the summary of all those values. And then here is actually what happened after the trade was complete. So here's the ETH balance before, the ETH balance after, the ETH spent. All right, the WETH balance before, that was 0, and the WETH balance after was 0.41. So you got 0.41 ETH. This is ARB. And then the total gain loss is this when you account for the gas fees. Okay. So that is exactly how yeah, it worked. That's exactly what the bot's going to look like whenever it calculates and finds an arbitrage opportunity, calls your contract. It just did it. We can see the transaction goes through, and we can verify what actually came to our contract here with this process. So yeah, I've got some good questions here in the chat. We'll cover these about swap events versus mempool. We'll talk about the mempool here in a minute. So what are the reserves? The reserves are basically the liquidity pools. So these are the reserves that I was talking about. So you can look at these addresses. Okay. Let's just see here. These reserves that are these pair addresses or reserves, you can take these addresses, pop them in the Etherscan or whatever block explorer you're looking at, and you can see those here. Like here's the Sushi Swap reserves with the Shiba Inu tokens and the wrapped Ether tokens, and then here's the Uniswap, with the Shiba Inu and wrapped Ether. So those are the reserves on each exchange. All right, so somebody's about pointing to mainnet. So that is an overview of how you can run this on a sandbox environment to watch it happen. And I highly recommend doing this so that you can sort of just get your hands dirty, understand how it works, and then change this to maybe look at a different pair, maybe manipulate some different prices, or even point to a test network. So let's talk about how to actually point it to a different network, okay? So the first thing you can do, I'll go over this in a minute, but like you can use config.json. Okay, so here's where you can put in your project settings. Like here's the Uniswap addresses, the SushiSwap addresses, but you can also look at the project settings, which is local. All right. This is telling you whether it's going to look at the mainnet on Ethereum, or if it's going to look on the local Ganache test network. So by default, is local is set to true. So we're looking at our Ganache network. Is deployed is talking about, is your contract deployed or not? So what I'm going to do right now is just set this to false, which means our contract is not deployed. But I'm going to say it is local to false, okay? And that's going to actually make our bot run against the Ethereum mainnet and just monitor the events. So I'm just going to do node bot.js. Let's see if it finds any swaps. We'll just let it sit here and run for the remainder of the presentation, and let's see if it logs any swaps. It won't actually fire off any swaps because we told it that the contract is not deployed. But if you just want to run your bot on some pairs and see if it's actually detecting those trades, you can do that as a good practice exercise too. Okay, so now that's a demonstration of the bot and getting it up and running so that you can see how it works. Let's talk about, let's actually go through the code and explain it in depth, okay? And then talk about how to customize it. So let's start off with the arbitrage contract itself, all right? So I'm gonna scroll to the bottom of this. This is all in one file just for simplicity's sake. But essentially, this is the arbitrage contract. So here's where it starts on line 149. It's a smart contract. It's called arbitrage. It inherits from the DYDX flash loan contract. So this is just, you don't have to worry about how all the DYDX flash loan stuff works under the hood, okay? It's like you don't have to worry about like, how some of this stuff works necessarily. Okay. You just like these lines, you don't have to worry about that. You just have to know that essentially it has two specific functions. One is a flash loan function. This is the function that you use to borrow money from DYDX. It just has a couple different arguments like the token and the amount and any data you want to pass in. And then your smart contract has to implement a callback function, this call function, okay, in order to actually receive the flash loan and pay it back. So let's sort of trace that logic through. So our smart contract, let's start from the top. So we have a constructor function that gets run once and only once for the contract to load the blockchain. It has a couple different settings, like the SushiSwap router address for the token that you want to deploy, or sorry, to arbitrage, and then the Uniswap router address, okay? So we have those inside of our .env file. So here's the token that you want to arb for and against, and then whenever we deploy the contracts here into the migrations file, okay, we show you what those router addresses are. Okay, well actually, sorry, they don't come from the .env, they come from this config. So config.json shows you Uniswap router address and the factory address. Okay, so it reads those inside your deployment script, and then actually injects those into the constructor function when the contract's put on the blockchain. And of course, your wallet that you deployed the contract with will be the owner. All right. And then we just save those some state variables. Let's talk about what happens when the trade happens, because of course, this is going to do a flash loan. All right. So inside of execute trade, we have some arguments. All right. So this is start on Uniswap. This is true or false. This is just a variable. We tell the token, the first token that we're using, the second token, and then the amount of money we want to take out with the flash loan. We track this inside the function. We just keep the balance before. We just check the ERC20 balance of the contract address before we do the trade. And then we put all this into some data that we can pass in this flash loan function. So whenever we execute trade, all it really does is set up all the variables and then call to DYDX to do this flash loan, okay? So you can see flash loan, where does that come from? It comes from up here inside of DYDX, this flash loan function. This is the function that actually says, hey, DYDX, I want to borrow these tokens, all right? This is the token address, this is the amount, this is the data that I need to use whenever I get that flash loan. And so DYDX specifies that whenever you call this flash loan function, you have to implement a special function on your own smart contract that triggers, okay, whenever you receive the money. So basically DYDX says you need to have a special function on your smart contract named call function, okay? So we have a function inside of here called call function, all right, named call function, because that's what DYDX says. So basically, it's going to have these specific arguments that DYDX specifies, like the address of the sender, the call data that we passed in, the bytes data, okay, here. And then whenever we receive the money from DYDX, we unpack all this data that we sent to it, okay? We packed in all this data here. We passed it in here. We unpack it here. So now we have the variables that we work with, start on sushi swaps, true or false, token 0, token 1, the flash amount, balance before. And so we just make sure that we got the loan here, okay? We basically just say balance after minus balance before equals the flash amount. So we make sure we got the flash loan, all right? We don't want to execute anymore if something happened here. And now here's where we use the money, all right? So what we do is we essentially set up a scenario where we create, an array that keeps both tokens, all right, token 0 and token 1. So if we start on Uniswap, then essentially we're going to swap on Sushi Swap with this path. So here's the first token, here's the second token. We pass in the flash loan amount, all right? And then that's the first trade to swap on Uniswap. And then the second path for arbitrage, we reverse the order. So we go token 1, token 0, and then we swap on Sushi Swap. So basically, if you're starting on Uniswap, you swap on Uniswap first, you reverse the order, and then you swap on Sushi Swap, okay? And then if you don't start on Uniswap, you do the exact opposite, just like this, all right? And then you can see what happens here, swap on Uniswap. Basically, we just use the Uniswap router. We call this specific function called swap exact tokens for tokens. I'll just show you that in Uniswap documentation. So this is the Uniswap router function. Swap exact tokens for tokens. It just says the amount in, the amount out minimum, the call data, the address to, and the deadline. And so we do all that right here. Amount in, amount out, pass, address this. We do the block timestamp plus 1200. All right. And so for Sushi Swap, because it works the exact same as Uniswap version 2, we just do the exact same thing, but we do it in the opposite order, okay? So we just pass in the address, we do the amount in, amount out, path, address this, block timestamp plus this, okay? And then finally, whenever we're finished, we take the token and then we transfer the tokens that are left, okay, in the contract minus the flash loan amount, and we send them back to the owner. So the tokens, don't stay in the smart contract. After the function executes, it sends them back to the owner address, which is the wallet that deployed the contracts to the chain. So where do we type in the flash amount? So that's going to be inside the bot. So let's go ahead and look at the bot. So how do we, so somebody's like, how do we get the flash amount? Yeah. So it's passed in. Okay, we pass that into the execute trade. So all that's going to happen inside the actual bot itself. Okay, so let me pull the bot up and I'll show you how that works. So now let's go to the bot script. Okay, so that's this process that was running over here. Okay, so here, what's cool is I'm gonna take a quick detour. Remember a second ago I said I was pointing my bot to the mainnet? So it actually found a swap event. Okay, it saw there's a price difference here of 0.15%, but unfortunately, there's no arbitrage opportunity currently available because the price difference is not enough to do it with the gas fees. So, yeah, that's. I just want to show you the bot is actually working. It's looking at mainnet. It just didn't currently detect an arbitrage for that particular pair. Again, this is just one trading pair on 2 exchanges. You can multiply this times a zillion across all those opportunities I talked about before. So let's go into the bot script. All right. Okay, so in the top, we have some configuration that we pull in. Okay, we pull in this configuration.json file that shows you all your project settings. Okay, as it deploys local. Here's the Uniswap addresses. Here's the Sushi Swap addresses. Okay, we pull those in at the top of the file here. We have a helpers file over here. Okay, where we pull in some initialization helpers that configure the project. Okay, we have some helpers that essentially help you determine like the token contract, the pair addresses, the pair contract, get reserves, calculate the price difference, get estimate return. Okay, and we pull those into our bot here at the top. Okay, and we get like the Uniswap factory, the router, the Sushi Swap factory, all that type of stuff from the initialization. Okay, we put in all of our environment variables from our .env file. Okay, the arb for, arb against, the units. All right, the price difference, the gas limit, the gas price, and then we have this main function that essentially does that watches for the events, and then we have all this code down here that actually does the arbitrage itself. Okay, so let's look at the main function. So the main function is what is constantly watching for arbitrages. That's what's running over here when it's looking for these swap events. So before I was talking about how essentially what this is doing is it's watching every single swap that happens in this particular pair of these exchanges, and it's listening for events from the smart contracts to do this type of thing. Okay, so essentially, like every time a swap happens, it's gonna evaluate that swap. You know what happened, and can you now essentially do an arbitrage? So we have two different things here. On line 30, we have the Uniswap pair, and then on line 59, the Sushi Swap pair. And essentially, it's just getting the events and it's listening for every single swap event that comes in. So on Uniswap and also on Sushi Swap. Okay. And so it says, like, basically, it calculates the price difference. We have this check price function in our helpers. For Uniswap, we give token 0, token 1. It gets the router path for the Uniswap router. We have a helper that checks to the direction, okay, based on the price difference. And it basically says, if it's profitable, we determine profitability here, then it'll do the trade. All right. Now, if it's not profitable, it'll stop execution and say no arbitrage currently available. That's what we saw here a second ago. But if it is profitable, this, of course, will be bypassed, and we'll go here to execute trade, and it will do the trade. Same thing for Sushi Swap. It's the exact same code, basically. It just does that for the Sushi Swap events, okay? So let's go through each of these. We'll start with check price, all right? So check price comes from the helpers. Actually, hold on. Check price is down here. It uses the helpers down below. So check price, what it does is it essentially gets the current block, okay? But it gets the Uniswap price with calculate price. That's what comes from helpers. Okay, so we do calculate price. Basically, we get the pair contract. We call get reserves. Okay, which is the function from the Uniswap documentation that basically just gets the amount of cryptocurrency in each liquidity pool. Okay, and then it essentially divides those two to get the price. All right, remember I was talking about before how basically you get the prices, the ratio of the two tokens on the reserve. So that's how we calculate for Uniswap. And then we do the same thing for Sushi Swap. We get the pair and we call calculate price. We just fetch the amount of cryptocurrency in each pool and we calculate those prices. Okay. Now what we do, we get the fixed price here with this amount, okay, with the Uniswap price. And then we calculate the price difference. So we subtract the two, we divide it, and then we multiply by 100, and we round it to 2 decimals here to show you what the price actually is. And it gives you an actual price difference. We log it to the console, but then we return the price difference from the function, okay? And so here's the price difference, okay? And then we determine the direction, so we get the router path, which comes from determine direction. So basically say if the price difference is bigger than the difference, then essentially return this path, Uniswap router, and then the Sushi Swap router. If the price difference is less than or equal to this, okay, then do the opposite. So Sushi Swap router, then Uniswap router. So that's about the trade direction, which exchange you want to start on, which you want to finish on. Okay. And then here's how we determine the profitability. We use a determine profitability function. We pass in the router path, the token 0 contract, token 0, token 1. And then we do this. Basically, we check the router addresses, okay? And then basically say, we get the reserves again, all right? And that's going to tell us, which pair we're using. And here is how we actually calculate it. Oops, sorry. So what's going to do, we use a function on Uniswap called get amounts in. Okay, this is going to tell you how much WETH that you're going to need. Okay, someone's asking me about how much are you going to need for your flash loan to do the actual loan. Okay, then basically this is what it's going to tell you. You actually ask Uniswap, how much cryptocurrency do I need in order to make this trade? And it will tell you the answer. Okay, so this is the actual function from Uniswap. And then we get amounts out. This is how much cryptocurrency we expect to get back from this trade. And then we log all the information to the console. Okay. And so for get estimated return, okay, we get the amount in and then the amount out. All right. And then we just tell you like how much was the ETH balance before. This is all just, logging difference. All right. This is just saying, hey, how much cryptocurrency do you have in your account before? How much do you have in your account after? All right. And so here's the WETH balance before, WETH balance after. And then we just calculate the total gained, WETH balance difference. Okay. And we log out to the console. And then basically, if the amount out is less than the amount in, it's not profitable and return false. Okay. But if it is, then we say it is profitable. Okay. And inside of that, we also, in calculating the ETH balance before and ETH balance after, we subtract the estimated gas cost of the swap itself to factor in the gas costs for the profitability of the arbitrage itself. Somebody says, can you run multiple bots at once? Yeah, you can definitely run multiple bots at once. So if we use a DEX that does not have V2 router, do we have to change the code? So whatever interface that you're supporting, you'll have to support that particular DEX's interface. That's the reason we use the Uniswap version 2, is that it's a pretty uniform interface on both exchanges. And also there's so many different exchanges that use Uniswap version 2. Just like if you go to DeFi Llama, you look at forks, you look at Uniswap forks, there's 343 forks. Okay, and you can actually click in on this and you can see all the Uniswap forks. So all these exchanges that are forked Uniswap version 2 are using the exact same interface that I'm showing you right now. Okay, so let's look here. Term profitability. Finally execute trade. That's down here. So this is where you get the router path, the token contract for each one. And then basically we determine whether we want to start on SushiSwap or Uniswap. And we just compare the addresses of the router path. And if it's a Uniswap router path is the first item in the zero-based index array, then we'll start on Uniswap. We'll set that as variable to true. We get the account. All right. We get the balance before, the ETH balance after. And then we talk to our arbitrage contract. We say methods execute trade. Okay. That's exactly what's in here. Just pull this out of here. So hold on. So now the execute trade function, we need these variables. All right. So start on Uniswap, we evaluate that here. We just put in the first token address, the second token address, the amount, okay, which we calculated, which we calculated before. And then we call send. All right, we do it from the account that we're connected with. We pass in the gas. And then when it finishes, we log the trades complete. We fetch the balances after to determine that, yes, it successfully went through. We show how much was spent, and then we show all the profitability data here and log that to the console with a nice table. And then here is where we actually start the application. Okay, again, this really runs inside of a big main function. So this is just defining the function right here. And down at the very bottom is where we call the function, and the bot runs until you stop it. So Gerard says he once made around $100 a day. Quite different long tail strategies on Binance Smart Chain. Lasted for a month before competition increased. Yeah, totally. That is definitely one strategy, is doing smaller ARBs that add up, that you can multiply across time. And again, a lot of that's about doing stuff before other people are doing it. So I'll go ahead and move to an extended time of Q&A here. I'll go ahead and drop your questions in there. I'm gonna talk about the price manipulation script here in a second. But I see some questions coming in. Do we need to run this on a computer? I mean, a cloud? I mean, you can run on your computer. I would recommend, if you're gonna, develop a strategy and run it 24/7, you're gonna have better uptime in the cloud for sure. You can run it on a, Amazon EC2 instance, a Google Cloud Compute instance. So here's a manipulate price script just for reference. Basically, this is the script that we use to manipulate the Shiba Inu tokens. Okay, basically we unlock the account. We get the ERC20 token here for SHIB and for WETH. And then we just do this manipulate price, which essentially just talks the SushiSwap thing. Sorry, the SushiSwap DEX, and it approves the tokens first, and then it does swap exact tokens for tokens, which is the exact same function we use inside of our smart contract. So you could change this for a different token if you wanted to configure that yourself for a new strategy. So liquidation bots. It's also a hot topic. So do we get this code? Yeah, you get the code. The code's down in the description below. Okay, yeah, it's a good question here. So, how does Flashline ensure the in between the swaps as one whole block? Is it not like as a rollback in normal coding? So, yeah, it's a great question. So, basically, whenever you are swapping, the Ethereum virtual machine processes transactions one by one. And so whenever you're doing your transaction, you're basically the star of the show. And so, inside your arbitrage contract, it's doing, call flash loan and then call function. So all this is happening inside the same transaction. So if you don't pay back the money and your trade's not profitable, like it's not going to go through and it's going to fail. Can you use the same principles to run a leverage yield farming bot? Yes, you definitely can. So we've got a full solution for that inside the blockchain mastery video vault as well. Okay. So how you run multiple bots? So you could do this a couple ways. So you could, of course, modify your contract to support multiple pairs. Okay, I mean it already does. You can give it arbitrary tokens. Okay, it's only supporting 2 exchanges, right? But you could change anything that has like a Uniswap interface. You could easily run that with. So in terms of running multiple bots, you can run this exact same bot to look for different pairs by literally just starting. Your bot with different environment variables. You could just start the process on multiple instances in the same thing to change the settings, or you can actually update the code to simply have an entire manifest of pairs that you're looking at to run into the same process. But I want to make this as straightforward as possible so that you can see explicitly how everything works. Because if we're sitting here working on a bot that has all these like fancy bells and whistles and customizations, like it's going to be really hard to understand how it works and how to explain it. And I want to make this as explicit as possible so that you can see exactly how it works. So you're not here scratching your head going like, okay, how does this work? How does this work? This is about as straightforward as you could possibly make it. Okay. So Gerard says, what's the best way to learn trade simulations in order to avoid honeypot tokens? Have a resource somewhere. So maybe clarify a little bit more about what you mean by that question, Gerard. So it's Linode Cloud is his choice. Luke, that's what he says for running cloud-based applications. Yeah, you can check out Linode. So what does manipulate price do again? So manipulate price is what takes the Sushi Swap tokens and dumps them on Uniswap from that Sushi Swap wallet that we looked at. So basically, like you can see this wallet here. We unlocked it and we dumped a bunch of tokens on SushiSwap to cause a price discrepancy. Because whenever that price discrepancy happens, that's ultimately what causes the arbitrage opportunity to happen. So you can see my bots are running, and it's looking at new swaps coming in. So how would you best choose pairs? The best way to do that is basically some manual research of just looking at different pairs and watching the amount of trading volume happening on those pairs, and also just running the strategies. So one thing is you can do is basically like looking at pairs that, I mean, sometimes pairs that aren't even that actively traded can yield opportunities as well. So basically, I'd like to simulate if selling works properly before you even buy. So honestly, like that's what this whole environment is for. So if you're like running a bot, I mean, it's gonna be hard to like simulate the buy in real time before you attempt the trade. But if you're developing a strategy, like that's exactly what this is for. So basically, like, you know, if you wanted to, like, one way you could practice this is if, like, I get what you're saying, Gerard. Like, it's going to be hard to have, um, like a test where you can, run the simulation in real time before you attempt an actual arbitrage transaction, because I don't think it's gonna be fast enough. Like you're gonna lose out on the time that you would run that simulation. But what you can do, and this may not necessarily answer your question, but this is a good idea for other people, is that you can, when I show you can fork ganache, you can also specify the block number. So what you can do is you can look at other instances of arbitrages that have happened on the mainnet on whatever blockchain, copy the block number, and then essentially fork your blockchain at that block number and then rewrite the code that performs that same arbitrage or a similar arbitrage. And that's a great way to practice as well. Can I explain how the code knows how much loan to make? Yeah, it's a great question. So I'll recover that. So essentially, what that does, let's just see here. So we do it with the amount, okay? And we set the amount. Let me just find it. Hold on. So we calculate that here. All right. So basically, we calculate the amount in here. So basically, we get the result from the router path, get amounts in. This will tell us, like we talk to Uniswap directly, and we say, how much cryptocurrency do we need in order to make this trade? Uniswap will return that amount, and we use that right here as the amount we're going to flash loan. Okay, hold on a second. Is hard hat better than ganache? It's got its benefits for sure. I also like hard hat. Where do you set the profitability for the bot to look for trades? So that'll be in determine profitability. So this entire function is what does that. So it calculates several things, okay? So it gets the amount in. It does the math, like the estimated gas cost. So you can adjust the estimated gas cost. You can use a more advanced technique like Web3 estimate gas. We subtract the flash loan amount as well. So we do all that calculation inside of this determine profitability function. So when I trade with Balancer, is not a Uniswap fork. Does that make things difficult? So it will change the complexity of what we're doing here. You will have to modify the contracts to support that particular exchange and also modify the bot to check the prices on those exchanges. How to add pairs and dexes. So dexes, I just covered that. How to add pairs. You can look at these pairs in the config. So let's see here. Config.json. Here's the pairs. So does the arbitrage contract work just for Uniswap, SushiSwap? It works for Uniswap version 2 style dexes, which this entire list is here. You can see all these different Uniswap version 2 dexes on DeFi Llama. You go to DeFi Llama, look at forks. Go to forks, click on Uniswap, and it'll show you all the Uniswap dexes. So can this be applied with XRPLs, DEXs? I'm not sure exactly the interface for those DEXs. Is wheat a constant? Yeah, it's going to be a constant. All right, so how to implement different strategies. So basically, the strategies like I was talking about before, the easiest way without major code modifications is just going to be looking at different pairs, okay? And then different, which you can change here. And then also, maybe looking at these on different EVM compatible blockchains that use Uniswap version 2 style exchanges, and then looking at different pairs. So that's going to be the easiest way to customize a strategy. You can definitely get more advanced in that. So let's start off with the easy way. So you could essentially deploy your contract to a different chain, like Polygon, for example, and use 2 Uniswap version 2 DEXs that exist on that chain, okay, and then look up 2 different pairs on that, okay. Well, before you even try a new chain, you can just look at the same chain and then just do 2 different pairs on these exact same DEXs, okay, and then you can switch up the DEXs. If it's Uniswap version 2 compatible, you just swap out the Uniswap version 2 router addresses and SushiSwap router addresses for that particular DEX that works the exact same way, okay. And then, but if you're talking about, and then you can multiply that strategy for a new chain that supports the same types of interfaces. Now, if you want to get more complicated than that, that's where you got to really dig into the code. Okay. So that's where essentially you would have to implement the swap mechanism for that specific DEX. Okay. And then swap out, instead of swap on Uniswap and swap on SushiSwap, you would actually need to implement the code for how that particular exchange does its swapping. Okay. Then you also have to modify the bot code to determine how they, calculate the cryptocurrency in their reserves. That's going to be a little more advanced. I'll be, 100% straightforward with you. But, now that you've seen how this works in a very explicit fashion and you can get good this, like going with the training wheels before you start trying to fly the airplane completely, like that's what you want to learn first before you try to, rip out the guts and make it work for something more advanced. So the code, the zip file, the rewatch, yeah, totally. Can you borrow other tokens? Yeah, you can totally borrow other tokens. So great job explaining. Awesome, thanks. So how do you factor in slippage? So you factor in slippage with the get amounts out. So is there a more lucrative swap for the bot in your opinion? So I mean, the swap that we did tonight was really, we made the swap happen ourselves. So slippage, we just talked about that. Or would you add live gas price? So that's a great question. You could essentially fetch the gas price right here. So basically, we have some manual settings for gas limit and gas price, but you could get those live in real time, replace these, okay, and then run those functions perhaps inside this main function. How would you run this on Matic? You would essentially deploy your contracts to Matic. So you could essentially, inside your shuffle-config file, you could point to the Matic network here, rerun your migration scripts, and then for your bot settings, okay, inside the helpers initialization, you would just point your URL here to the Matic RPC endpoint. So can you listen to events on swap on every RPC? Yes, you can. Could you run a Docker instance? Yeah, you could totally do this in a Docker instance. Could you make this run multiple pairs at the same time? Yes, you can. You could refactor the code to do that, or you could really just restart the instance multiple times looking at different pairs. Could this be done for triangular arbitrage? Yes, you can do a triangular arbitrage. You'll need to you'll have to update the smart contracts to do that though. As security of the contracts implementing or impacting what we're running, I mean, there shouldn't be any, well, I'll put it this way. I am not warranting this code to be 100%, security audited. So you definitely will run this at your own risk for sure. But in terms of, somebody being able to hack your contract, steal your funds. The bot doesn't really custody any of your money. Can I ARB on XRP ledger with flash loans? So I haven't personally tried to do that. Oh, okay, gotcha. So Gerard says basically some like low cap cryptos don't allow selling or putting you on blacklists. I see what he's saying here. So he's talking about honey. I do the same with honeypot tokens. Basically, like you buy into a crypto. I get what he's saying. Basically, like it's like scam coins where you buy it on Uniswap and then you can't sell it. So yeah, the best way to do that, I mean, like your transaction's not going to fire, right? Like if you try to ARB and you borrow the funds and you ARB for it, like it's not going to, like the transfer function is going to fail and your transaction is going to fail. So the only way to find out about that before it happens is really just to know what cryptos like you're ARBing. You know what I mean? So because at the end of the day, like you want to ARB back into a token that essentially you want to hold. So liquidity thresholds, it will determine the liquidity threshold based upon the smallest reserve. Oh, so somebody says you haven't seen anything in the determine profitability function about the trade volume. So the trade volume, the trade profitability, determine profitability is really just the profitability of the actual opportunity that exists. So there won't be anything that actually inspects the trading volume on a historical basis. Okay. Yeah, it doesn't do that. So ways to increase bot speed is that what's called front running. So that's two different things. So front running is essentially like getting into the mempool and looking at your transaction and getting in front of it, submitting it at a higher gas price or something like that, that essentially puts your transaction first versus bot speed. So there's a couple of ways to combat that. Okay. So one, in terms of bot speed, running your own node is definitely going to give you an advantage in that regard to submit, transactions and get information faster. If you want to get information faster, other ways are basically to use a private, private service like Flashbots to submit your transactions. Somebody was talking about before about inspecting, trades through the mempool instead of swap events. And you can definitely do that too. You can modify this to essentially look at swap events that are happening inside the mempool before they're actually published to find about opportunities first. Okay. You can definitely check out something like Block Native, okay, to get mempool view to look at swap events before they're actually published to the chain. So you can also do that as well. Is there opportunity to practice arbitrage on test nets? Kind of. It's harder though, right? Like that's why we're doing it here inside the sandbox environment with the fork, because it's got all the same addresses, it's got all the same tokens, and we can ensure that there's trading volume. So are smaller trades more successful? Not necessarily, but they can be. Can you recommend a website that shows most active trading pairs? Yeah, I would just look at something like uniswap.info or even DeFi Llama. Okay. Like Uniswap. Okay. You can look at like, they'll show you top tokens, top pools. You can go through this page. So you just change the router address and that's it for new DEX. A new DEX that implements the Uniswap version 2 interface. So we explain the local and is deployed section. Yeah, sure. So the config.json is local. Just says the bot that you're running here, is it looking for is it watching the mainnet or is it watching your local blockchain? So if it's false, it's watching the mainnet. If it's true, it's watching your local blockchain. So is deployed is about your smart contract. So is deployed is false. We have not put our contract in the blockchain. It's only been put on our local. So if we put this to true, that would be watching for a smart contract on the mainnet. Is Alchemy fast enough for real-time trades? It is, depending on what you're doing. But if you are trying to go after really competitive stuff, you're going to have that advantage of having your own infrastructure. So basically, its code is pretty much concrete. First, focus on config.json, switch out the DEX addresses. Should we include the flash loan account on that part of the code? So I would just leave the flash loan account the same. Does DYX need a VPN or the KYC? It's a good question. So DYX requires a VPN if you're a US customer. That's just if you're using their front end, okay? That's just their website. So if you have access to the smart contracts, you can take out flash loans. So that's got nothing to do with derivatives trading. That's just about taking out loans. What kind of tool can we use to monitor, alert the bot performance? Is there a good repo for this? So yeah, a really easy way is like you could basically, I mean, you know, in terms of just watching the profitability and the you know, the trades. I mean, you can watch the transactions on Etherscan to see what was attempted and what went down. In terms of monitoring the activity, I mean, the easiest way is just to like log out the server output. Okay, you could add some sort of monitoring tool, like if you want to send yourself a Telegram message or something like that. You can create a Telegram bot and then put it inside of the app. Anytime a trade happens or it finds an arbitrage, it could send you a Telegram message. Is it hard to upgrade smart contract once it's deployed? So you need to redeploy the contract. Okay, so mint profitability based on the size of a trade. I didn't see how the trade size was calculated. So the trade size is calculated in here. So basically, inside of this is the trade size. So we talk to the Uniswap router and we say get amounts in. That's going to tell us how much we're going to trade. Uniswap is the one that actually tells us how much we're going to trade. Is our contract deployed to the mainnet? Is there a cost to deploy the contract to the mainnet? So the contract right now is not deployed to the mainnet. It's deployed to your local blockchain that's forked to the mainnet. So yes, you will have to pay a gas fee in order to put the contract to the mainnet. Does Ganache forking follow new blocks? No, it freezes it at the current block that you forked at. Can you connect more than one exchange to monitor for arbitrage opportunities? Yes, you definitely can. I mean, this is going to look for 2 exchanges at a time, but you could run the process multiple times, pointing to different exchanges. You can code a more sophisticated bot that watches multiple opportunities, but this is very binary. So how did this snapshot fork allow for prices to move on the dump of SHIB? It's a locked snapshot. So it is a locked snapshot, but then you're able to apply your changes on top of that snapshot. So you fork the Ethereum mainnet at that snapshot, but then you can manipulate and add new blocks after that. So are there ways I can learn to find arbitrage opportunities instead of waiting? More active approaches. I'm assuming it will involve a lot of math. So yeah, I mean, you can do what the person was talking about before with triangular arbitrage. We have videos inside the Blockchain Mastery video vault on triangular arbitrage. You know, but the easiest way is just watching multiple exchanges, multiple pairs, multiple chains, multiplying, you know, different trading pairs, all that type of stuff. How will we implement a Telegram bot to do the successful trade. And then I'm going to have to wrap this up here in a minute because I do have I think my thing only works for 2 hours and we're about to run a 2-hour limit. So you can look at Telegram bot API. You'll have to register a bot. But basically, I won't get too in depth on this, but basically you go through the bot. It's got documentation. I set one up, but you just need to pull that into your project, create some sort of API key, and then basically whenever it finds an ARB, just trigger the line of code that sends you a message. All right, so I give a 5-minute warning here, then we'll go ahead and wrap this up. Does the SIP5 have instructions on how to deploy the smart contract to the blockchain? Yep, sure does. They are right. I'll pull them up on my screen here. So here is the mainnet instructions and some more additional README. So it's also on stock exchange. Unfortunately, DYDX discontinued solo margin, therefore their ability to carry out flash loans in November 2021, but use flash loan. Yeah, it still works. Is the ABI of 1inch open somewhere? Yeah, you can definitely use 1inch exchange for arbitrages. I've personally used 1inch exchange. The ABI, basically, you just want to look up 1inch. There you go. 1inch router. There's the ABI right there. Is it necessary to deploy the contract to mainnet? Any advantage in deploying to mainnet? I mean, you don't have to use the Ethereum mainnet. You can use a different mainnet, but in order to do any kind of arbitrage, you have to have the smart contract to the blockchain. How do you find the huge balance account with SHIB to manipulate the price? So it's in the README, okay? But if you want to like learn how to find one yourself, you could just go to Etherscan for a different token, for example. Say you wanted to look up the Uni token and ARB that token as practice, you would just go to the holders tab and then look at like some of the largest holders and then just like look at this one, for example, and then you just like take this wallet, okay, and you'd see it's got like a bazillion Uni tokens. You would just rerun the script and then unlock that account. Is arbitrage backwards compatible? Yes. Yeah, it can work both ways. He says he learned more in this YouTube stream than in 3 years of finance major. Awesome. All right, so a couple more minutes here and we'll wrap up. So how much USD and MetaMask would you need to put in a beginner to make this code? So I technically can't give financial advice on that one. All right, everybody. So let's look out for today. As always, great class tonight. It's great questions. Everybody, thanks for sticking around towards the end here. We covered a ton of awesome stuff. Again, we're gonna We're gonna send out a live stream replay link that you can rewatch for this if you weren't able to follow everything. I realize some of this we had to move pretty fast. We had a few short hours this evening, but hopefully we covered everything, answered all your questions. Highly recommend watching that replay. Go ahead and grab the coding solution with that replay. It'll be emailed out if you join the one-time class tonight. And if you're inside of the blockchain mastery program, we'll post that in the blockchain mastery video vault along with the code as well. So again, super excited for all you guys, and until next time.